Hello again. In this video, we are going to look at finding limits graphically, both two-sided and one-sided limits. So you can find a PDF or a handout of this graph and these questions on Blackboard under handouts if you would like to print this or upload it like to use on a tablet or just have it. So I really encourage you to, before you get started and keep this video going, you actually take some time to see if you can figure out some of these limits, or at least try. And then once we go through it in the video, you can maybe help fill in some misconceptions or see where you're at with this. All right, so we have this, we don't have a formula for this. So this function that's graphed over here, the function f of x is the entire thing. So, it's got a lot of crazy stuff going on. We've got this hole here at -4. We have this vertical asymptote here at -2. Then we have this jump in the graph here at +2. So we don't have a formula, just have a graph. So we should be able to find limits just by given a graph too. Okay, so I'm going to just start with this first group here. Let's look at the limit as x approaches 3 from two sides. Okay, so here is x equals 3. Remember, we are approaching 3 and it's from both sides. We want to kind of go along the function from the right side and also from the right side. Wait, right side and left side. I think I got them backwards. And then see where this point is that they're pointing to. And there's nothing strange going on here. At x equals 3, it just is a nice filled-in curve. There's no holes, there's no jumps, there's no asymptote. And so it looks like it's really nice, right? Looks like it's heading towards about 2. Okay, so I'd say the limit as x approaches 3 here of the function would be 2. All right, let's look at x approaching -3. It's just going down this column. All right, -3. X equals -3 is right here. So we're going to hone in, let x approach -3, but on the graph. So it looks like they're going to be approaching this point here where nothing weird is happening. There's no jumps, there's no holes or anything. So we'll just approach -3 from the right-hand side. Looks like it's heading towards this point. We'll approach -3 from the left-hand side, heading towards the same point here. It looks like that y value is about 2. So this limit would be 2 as well. All right, x approaching -1, again from both sides. All right, so -1, x equals -1 is right here. So this is where we're going to be heading towards, but on the graph. All right, so from the right-hand side, we're just going along the function here. And as we approach x equals -1, looks like they're heading towards this point. And the same thing is happening as we approach -1 from the left. And so the limit here, again, there's no holes or jumps or anything. That's just going to be, well, the y value right here at this point, right? That's actually 0, right? So the y value there for the limit will be 0. Okay, the fourth one, the limit as x approaches 0 from both sides. So x equals 0 or x approaching 0, that's here. Right, so we're going to approach 0 from both sides. Okay, still nothing strange happening here, right? On the graph, if we approach 0 from the left, if we approach 0 from the right, we're just heading towards this point here. And that's just a y value of 2. So the limit there would be 2. My last one in this group is x approaching 4 from both sides. Okay, so +4 on the x-axis is right here. Again, nothing weird happening on the graph at 4. So it looks like, when this is the case, our limit is just the function value or the y value on the curve. So, but we can just see, so we're approaching this point here, right? So here it is from the right. Here we're going towards it from the left. And they're just honing in on this single point here, right? And that has a y value of +1. So it'll be the limit as x approaches 4. Okay, so this is actually what it looks like when you can just plug in the x value. or we were calling that direct substitution. Okay, when the limit and the function value are the same, when there's nothing strange going on in the graph, when you can just directly substitute in, graphically, that's what all of this group looks like. All right, we've got 3 more groups. Let's move over to the right-hand side here. So this is all about -4, x approaching -4 from one side, the other side, and then both sides. Okay, so that's where we have this hole in the graph. Okay, so this is going to be where we have a hole in the graph. All right, but remember that the limits don't actually see the point. They don't see what is going on at -4. So the hole isn't going to affect the limit. Okay, we're just approaching -4, but we never actually get there when we are finding the limit. So the first limit here is x approaching -4 from the right-hand side. So we have to remember, we're coming from the right. That's what the plus means. We're coming on the number line from the plus side. Okay, so we're approaching -4, but only from this direction. So we go along the function, and it looks like that, okay, even though there's a hole in the graph, again, the limit doesn't actually see that. We're just approaching -4. And so if we didn't know any better, right, the y values, we would say, are heading towards 1, right? And then so that's the value of this limit, it's +1. Okay, -4 from the left-hand side is the next one here. Okay, remember this notation with the minus on the kind of like exponent. So -4 from the left side, or from the negative side on the number line. So we're heading towards -4 from this direction. So we go along the function towards approaching x equals -4. And again, even though there's a hole there, the limit, what are these values approaching on the y-axis? They're heading towards a y value of 1 again. And so that is 1 as well. Okay, the next one is the limit from both sides. Right, whenever there's no plus or minus at the end, that is the two-sided limit from both sides. So here we've got, it looks like as we approach -4 from both sides, we're pinching in on the same point there. So this limit is going to exist, as opposed to DNE, or does not exist. And it's just as equal to the y value, the same as from either side. Okay, so when these two are equal to each other, then the two-sided limit exists and is also equal to the two one-sided limits. So that'll be 1 as well. F of -4, here's where we do care about the hole, right? Because f of -4 is what you would get when you plug in x equals -4. And we can't do that, right? We get like 0/0 when we have a hole in the graph. Okay, so this we would say is undefined. I would stick to DNE, or does not exist, for a limit, and I would stick to undefined for things that are function values, or if you get a 0 in the denominator, that's what we would call undefined. Okay, so again, this is what it looks like when you have a hole in the graph, or 0/0 from direct substitution. I'll talk a little more about holes and these kinds of things in section 1.6. Okay, the next collection, going down to the bottom left, so let's look at this group here. This is all about x approaching +2. All right, so that's here where we have this kind of jump or break in the graph. All right, so first we're going to look at x approaching +2 from +2 from the right. That's what this plus means here. Okay, so we're going towards 2, but only from this side. So we're going to march along the function. And again, the limit does not see what happens at the point. We just are getting closer and closer to it. So even though there's an open circle here and a filled in circle here, the limit from the right is just heading towards +1. Okay, so that's the limit from the right-hand side at 2. On the other hand, the limit from the left-hand side, that's doing something different. right? As we approach 2 from the left-hand side, okay, with the minus here, then we're going along the function and approaching x approaching 2, approaching 2, approaching 2. And it looks like that the y values are heading towards not 1, but 3. Okay, so that limit here will be positive 3. Now, when the two one-sided limits, okay, these two here, aren't equal to each other, okay, we got 1 from one side, 3 from the other, then the two-sided limit, that's when we have a does not exist situation. So this will be D and E. Hello, iPad, wake up. There we go. Kind of. Keep going, please. Okay. All right, so, right, this is because those aren't equal, right? So the two-sided limit is D and E. Now, f of 2, we actually can plug in a 2 into the function here because there's, like a filled-in circle somewhere, right? As opposed to just at -4, we had just a hole. Here, this solid dot here, this means that when we get to 2, the y value that we will take at x equals 2, we're going to read that off up here, right? So that is equal to positive 3. Okay, our last set is looking at what's happening at x approaching -2. All right, so that's right here where we have this vertical asymptote. Okay, so x approaching -2 from the right-hand side. Okay, so that's from this direction. Well, if we go along the function and we get closer and closer and closer to -2, this arrow here indicates that the function is just going to keep on doing this behavior. It's just going to keep on going down, 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 and getting more and more negative. Now, a function does not ever cross its vertical asymptote. So this is just going to get, it's going to hug this asymptote, but it's going to keep on going down. It's not going to approach an actual number. The math symbol for that idea would be -infinity. Right, negative, but larger and larger and larger, just down, down, down. Right, so here we would say that this limit here would be -infinity. All right, from the other side, x approaching -2 from the left, so that's from this direction. Here we have the opposite behavior going on. Here we have the function is just climbing up and up and up and up and up and up. It's kind of the same, but here we're just becoming more and more positive, or larger and larger and larger. And so the math symbols for that we would say is just positive infinity. And again, these two don't match up. So the two-sided limit at x approaching -2, it would say does not exist. And here at a vertical asymptote, we'll talk more about this, but this is what happens when you get a 0 in the bottom of a function when you plug something in, but you don't get 0 up top, you get a number up top. So as opposed to 0/0, which gives you a whole, a vertical asymptote comes from a numerical value that's not 0 up top and a 0 in the denominator. So anyway, we can't plug in the value of -2 because we have this undefined behavior here, right? So we would say this is undefined. Okay, so and just to note this, so we'll see a couple examples with this algebraically. This would be a vertical asymptote, and this gives us some kind of number over 0 from direct substitution, a non-zero number up top over 0. Okay, so you have some practice on your homework with a really cool graph on your written homework number 2. You also have some practice on your web assignment, so take a try at this and make sure that you know what the notation means, also that you can read it off of the graph and have some fun. In the next video, we will finally talk about the best way to find limits, in my opinion, and that is by using algebra. So I'll see you then.